Right, 2.9B, we have to write each of this in logarithmic form. So as we discussed earlier, we take log both the sides with the base being the base of the exponent. So here the exponent is e raised to x plus 2 and the base is e. So I'm going to take natural log with base e both the sides, which is called natural logs, So natural log of e raised to x plus 2 is equal to natural log of 7. This x plus 2 drops outside and we know that ln e is just 1, so we disregard that. So the value of x comes out as ln 7 minus 7. Okay. Likewise over here I'm going to take log with base 5 both the sides. So log with base 5, 5 of 4, log of 4 with base 5 is log of 5 raised to negative 3x with base 5. Log of 4 with base 5 is as it is. This negative 3x drops outside and log of 5 with base 5 is just 1, which means that the value of x is 1 over negative 3 and log of 4 with base 5 is as it is. Then we have this one, so I'm going to take log with base 10 both the sides. So that's going to look like log with base 10 of 10 raised to x is equal to log with base 10 of x plus 3. X is thrown outside, so x is equal to log with base 10 of x plus 3. This is the final answer. Okay. Here we need to do the other way around. So the idea is first we determine what the base is, which is hidden because that's just e as it is natural log. So you keep the inside thing as it is. You throw the base over on the other side, which is e, and this is now on the power. So the final value of x is 1/3 of e raised to negative 2. If you don't want to write a negative exponent, then you can put that in denominator. So 1/3e square. Likewise over here, let's flip the omelet first. So log of x is equal to 1 and x is as it is. The base is hidden, which is 10. 10 goes on the other side and 1 goes on the power. So x is 10 raised to 1. And finally, over here, e to the x is as it is. 7 goes on the other side and 3 is raised to the power. So e to the x is 7 cube. Or e to the x is 343. Right, we have to evaluate the following. So we have to use the properties of log. Over here, I'm going to rewrite this as log of 2 raised to 4, right? 16 is 2 raised to 4 and this 4 is just thrown outside. So it will become 4 log of 2 with base 2, which is just 4. This negative 3 is thrown outside. So this will become negative 3 ln e will be equal to negative 3. That is the answer. Log of 1 over 1000 can be written as log of 1000 raised to minus 1. This negative 1 is thrown outside, so it will become negative log 1000. Log of 1000 can be written as 10 raised to 3. And 10 raised to 3 means this 3 is thrown outside, so it will become negative 3. And we know that log 10 is just 1, so the answer is negative 3. Well, negative 3 again, okay. Over here, log with base 3 of 27 can be written as 3 cube. 3 goes on the other side, so it will become 3, and then log 3 with base 3 is just 1, so the answer is 3. Log of 125, so I'm going to say that it looks like 125 is 5 cube, right? So 5 cube, and this 5 is thrown, 3 is thrown outside, and log of 3 with base 3, log of 5 with base 5 is 1, and apparently everything is 3 or minus 3. Wow. Okay, here we need to use a change of base formula. So I'm going to rewrite this as log 3 over log 27. And now it can be written as log of 3 over log of 3 cube, because that's what 27 is. 3 is thrown outside over here, so it looks like log of 3 over 3 log 3. These two are gone, so I'm just left with 1 over 3. Okay. Over here we have log of e raised to 12. That's pretty straightforward, right? 12 is dropped outside and we are left with ln e, and ln e is just 1, so the answer is 12. And log 1 is just 0. Log In fact, it doesn't matter what the base is. If we take log of 1 of any base, the answer is 0. Okay, more questions over here. So I think we need to use a change of base formula. So here I'm going to write this as log of 4 over log of 16 will be equal to log of 4 over log of 4 square. 2 is dropped outside, so it will become log of 4 over 4 log 4, which is, these two are gone, and I'm just left with 1 over 4. That's the answer. Over here we have log of 3 over log of 9 will be equal to log of 3 over log of 3 square. This 2 is thrown outside, will be equal to log of 3 over 2 log 3. These two are gone, so I'm just left with 1 over 2. Again, change of base, log of 7 over log of 49 will be equal to log of 7 over log of 49 is 7 square. This is going to look like log of 7 over 2 log of 7. These two are gone. I'm just left with 1 over 2. And finally, log of root e ln root e can be written as ln e to the 1 over 2. 1 over 2 is thrown outside, so it's 1 over 2 ln e, and ln e is just 1, so the answer is 1 over 2. Okay. Here we can write this as log with base 8 of 64 raised to minus 1. Minus 1 is thrown outside, so it will be minus of log of 64 with base 8. So this will become minus of log of 8 square with base of 8. And this is now thrown outside, so this is going to look like negative 2 log of 8 with base 8 will be equal to negative 2. This can be written as log of root 10 is 10 raised to 1 over 2. 1 over 2 is thrown outside, which is 1 over 2 times log of 10. Log of 10 is 1, so answer is just 1 over 2. Log of 1 over 2, so this can be written as log, first of log of 8, log with base 8 of 2 raised to negative 1. Negative 1 is thrown outside, so negative of log of 2 with base 8. This can be written as negative of log 2 over log 8, and log 8 can be written as log of 2 cube. 3 is thrown outside, so it will become negative log of 2 over 3 log 2. These two are gone, so the answer is just negative 1 over 3. Finally, question number 22, we have ln, this can be written as e raised to negative 5. Negative 5 is thrown outside, so negative 5 ln e, and ln e is just 1, so the answer is negative 5. More questions here. It's pretty straightforward, right? Pi is a constant is thrown outside. So pi ln e, and ln e is just 1. So the answer is pi. Here also we can rewrite this as log with base 16 of 4 raised to minus 1. Minus is thrown outside. So minus of log of 4 with base 16. So minus of log of 4 over log of 16, which will be equal to negative log of 4 over log of 4 square. This can be written as negative log of 4 over 2 log of 4. Log 4 is gone, so this is going to look like negative 1 over 2. This can be written as log with base 36 of 6 to the negative 1, which will be negative log 6 with base 36. This can be written as negative of log of 6 over log of 36. Yes, change of base formula. So negative of log of 6 over log of 6 square. Yes. And this 2 is thrown outside, so it's going to look like negative log of 6 over 2 log of 6, which will be equal. Log 6 is gone, so I'm left with negative 1 on the top and 2 at the bottom. Finally, 26, this can be written as log with base 2 of 32 to the minus 1. Minus is thrown outside, so log of 32 with base 2. So minus of log with base 2 of 2, 4, 8, 16, 32, 2 raised to 5. This 5 is thrown outside, so negative 5 log of 2 with base 2. And log 2 with base 2 is 1, so the answer is just negative 5. Right, not sure how this is related with logs. In fact, all the questions that we have that we are left with are not related to logs per se. I don't know why are these questions in this worksheet. Maybe it's a revision, but anyway, I'm just going to complete these questions. G of 0. So G of 0 is f of G of 0. So G of 0 is the value of G when x is 0. When x is 0, G0 is 1, right? G is 1. So this will be f of 1. And when x is 1, there you go, f is -6, right? So the answer is -6. Now this could be helpful for your SAT actually. F of -6. So where is -6? There you go. What is f of -6? When x is -6, f is 8. So this is going to look like g of 8. And when x is 8, there you go. When x is 8, g is going to look like -6, right? So it's going to be -6. Fun. Both are -6. F inverse 0, be careful. F inverse 0 means I'm looking where y coordinate of fx is 0. In other words, where fx is 0, which is right here. So the corresponding x coordinate is my answer, which is just 4. Over here, g inverse of -2. Again, be careful. I'm looking where g is -2, which is right here. And the corresponding x coordinate is -2. Corresponding x coordinate is just 1, which is just 1 over here. I'm looking for g inverse -6. So -6 is right here, which is the value of g. And the corresponding x coordinate is my answer, which is just 8. So this is 8 over here. And finally, I'm looking for f inverse 1, which means that wherever f is 1 is, I don't see f1 anywhere, right? Okay, so I'm going to say not possible. Okay, g inverse of 5, where is g5? G is 5 right here. What is the corresponding x value? Corresponding x value is -6. So this looks like f of -6. And where is f? Where is x -6? There you go. So f of -6 is the corresponding f value, which is just 8. So the answer is 8. F inverse 3. So where is f3? Yeah, there you go. 3. The corresponding x value is -2. So I'm going to say that I have to find g of -2. And where is -2? Right here. And what is the corresponding g value? It's 4. So the answer is just 4. Okay. What is g inverse 4? Where is g4? There you go. G4 is here. I mean, not G4. Where is G4? I mean, G is 4 here. So what is the corresponding x value? That is -2. So it will look like at f inverse -2. And where is f -2? Here. What is the corresponding x value? That's just 0. So the answer is 0 over here. Okay. The graph of a piecewise linear function, k is the inverse. Okay, k is the inverse, right? So what is k3? K3 is the corresponding x value when y is 3, right? Where is y3? Here. So what is the corresponding x value? Isn't this the point that we are looking for? So the answer should be -1. K of -1. Once again, where is y -1? There you go. What is the corresponding x value? That is 4. So the answer has to be 4 here. K of 0, where is k0? Right here. Now, what is the corresponding x value? Looks like 3.5. I'm going to go with 3.5. So this is the answer. What is the minimum value of k? Minimum value of k is basically the minimum, and remember, k is the inverse. So minimum value of k will be the minimum x value of the h, right? Minimum x value of the h function is -2. So that is actually the minimum k value. And what is the domain of k? Domain of k is same as the range of h, right? Because x and y are switched in function and its inverse. So domain of k is the range of h, and the range of h you can see is starting from -3, that's the minimum value, and going all the way to 4. That is the maximum value.